Hello there! This lecture is all about different types of data. So time series versus cross-sectional, qualitative versus quantitative or numerical data, and then most importantly, the different scales of measurement and whether or not a variable is discrete or continuous. So I imagine you're going to be looking back at this lecture quite a bit this semester because the decisions that you make in terms of which analyses are appropriate or which displays are appropriate is really driven by the types of data that you're working with. So in this lecture, I'm going to give you an overview of the concepts and then give you a really useful flowchart that you can use to make those kinds of decisions when you're doing your assignments and when you go off in the real world and you're doing data analysis there too.
So now that I've introduced you to the various sampling strategies used in research and the most common ones, now I want to get into the kind of data that is collected from those various sampling strategies. And we'll start off with the most broad categorization of data, which is qualitative versus quantitative. So qualitative is really just categorical data that allows you to classify something like sex or class standing, or to assess internal characteristics or processes. So like attitudes, behaviors, and personality, or maybe the quality of something. So qualitative is not numeric in nature, but quantitative data is numerical data. So something that's measured, like height or weight or drive-through time, or something that's counted, so like age, number of products sold. Qualitative data is actually usually quantified for the purposes of statistics. So for instance, the pain measurement scale or personality surveys, they both rely on numeric scores to make comparisons to others or to monitor changes over time. So if you look at this pain measurement scale here, if you ask somebody, how much pain are you in? They're not going to say, oh, I'm about a 5. Not inherently, but this pain management scale or pain measurement scale makes you able to assign a quantitative value to subjective feelings of pain, which is nice because you could compare yourself over time, right? So, oh, you were a 2 last week, now you're a 4. You've improved by 2 points. Or you could compare two different people. Someone's a 6, someone's an 8. Instead of someone saying, oh, I hurt, and someone saying, oh, I'm in a lot of pain, can't really compare that. But by assigning numbers to those, it makes it a lot easier to compare and assess. Another categorization of data is cross-sectional versus time series. So quite simply, cross-sectional data is just a cross-section, just a one-time instance of measurement. Whereas time series data involves multiple measurements across time. So if you look at this example here, we're looking at unemployment rates. If you look at the blue box, that would be time series data. So looking at the unemployment rates in the United States across time. So measured repeatedly across time. Then that green box represents cross-sectional data. So we're just measuring once, right? Just December 2015, looking at the unemployment rate, but we're looking at multiple groups at that one section of time. And Nevada is not looking so hot compared to the national unemployment rate. So the most detailed and most complicated distinction across different types of data is all about the scales of measurement. So there are 4 scales of measurement: nominal, ordinal, interval, and ratio. And I have these scales of measurement listed in order from the least complex and the least opportunities for data analysis to the most complex and that lends itself to many different types of data analysis. And you can think about the order in terms of noir, right? So Pinot Noir, N-O-I-R, so nominal, ordinal, interval, ratio, if you need help remembering. So let's start off with nominal variables. So nominal variables represent values that really have no meaningful order. It's really just some sort of category or some sort of group that can't really be placed into a meaningful order and has no inherent numeric value. So an example would be ethnicity. So ethnicity is not a number, and you can't place different ethnicities into a meaningful order or rank. Also, brand of soda, so like Pepsi, Coke, I don't know. That's not inherently numeric, no meaningful order. You may have some sort of bias that says, oh, Pepsi comes before Coke, but it's not an objective, meaningful rank. Another example of nominal or categorical variable would be political party. So there's different categories of political party, but it's not something that's numeric or ranked in nature. Now, the next level for scales of measurement would be ordinal data or an ordinal variable. And ordinal or ranking variables represent values that can be placed into a meaningful order. And ordinal variables indicate the direction of differences. So you know if one thing is greater than another thing within that variable. So for example, t-shirt size, right? Small is smaller than medium, medium is smaller than large, but those values aren't inherently numeric in nature. Another example would be class standing. So class standing, it's a category. It's not something that's numeric, but you know that a freshman has been in college for less time than a sophomore, and a sophomore for less time than a junior, and a junior less time than a senior. You know which groups are ranked in order, but you don't necessarily know the exact difference between groups. Some freshmen have been there longer than others, and some sophomores have been there longer than others. There's not an equal distance between categories or really a way to determine that distance if you're just asking about class standing. So, ordinal ranking tells you the direction of differences, but not necessarily the magnitude or amount of differences between values for the variable. Another example would be the place in a race. So you have to be careful, right? So you'd say first, second, third, fourth. Those look like numbers to me. But when you think about place in a race, it's just ordinal because there's not an equal distance between first and second, second and third, third and fourth. And those values, first, second, third, and fourth, don't really tell you the magnitude of differences between first and second and third, right? So the person who came in first and second may have been really close to one another, and maybe the person who came in third was way behind, but that information is not provided to you if you measure place in a race instead of measuring how much time it took for them to complete the race. If you measured how much time it took for them to complete the race, then you'd be getting into interval and ratio types of scales of measurement. So before I get into interval and ratio, I want to note that although nominal and ordinal data are often not numeric in nature, the categories and ranks are almost always assigned numeric values for analysis purposes. So for instance, if we had a nominal variable like sex, right? That value means, a numeric value means nothing, but you would still, for the purposes of analysis, assign numbers to those groups. So for instance, you would assign a 0 to male and a 1 to female. An ordinal example would be, so like the pain scale, right? So 1 to 10, or even class standing. So for the purposes of data analysis, you could assign 1 to freshman, 2 to sophomore, 3 to junior, and 4 to senior. See, in that case, the number's not arbitrary like it was for sex, but that numeric value doesn't give you the richness of information that you would need to call it an interval or ratio variable. It's just ordinal. So now let's get into interval and ratio data. So these are variables that are truly numeric in nature. And interval and ratio are very similar. The only difference is that ratio values have a true 0 point, such that a 0 score means a complete lack of whatever's being measured. So 0 represents none of whatever you're measuring. So also interval and ratio variables, not only do those values tell you the direction of differences, so you know which one is greater than the other, but also the magnitude of differences. So you know by how much of a difference there is between scores. So an example of an interval variable, or something that is truly numeric in nature, indicates the direction and distances of differences, but doesn't have a true 0 point. So interval data would be like a golf score. So a golf score can be negative. If you have a true 0 point, you're not going to have negative values. And a golf score is truly numeric in nature. And you know that if somebody has a 1, then they had 1 extra putt over par. If somebody has a 2, they had 2 extra putts over par. So not only do you know that someone with a 2 had more putts than someone with a 1, but you know how many more putts they had. Another classic example of interval data would be temperature. 0, not a true 0 point, right? If you're measuring in degrees Fahrenheit or Celsius and you have a 0 degrees, it doesn't mean a complete lack of temperature, right? None of it. It just means it's really cold. Also, you can have negatives for temperature, so that's a good sign that it's not a ratio variable. Another example would be, let's see, for interval, so Likert scales, right? So typically, Likert scales measured from, if you're measuring like satisfaction, so how satisfied are you with your job? From not at all satisfied to completely satisfied. A 0 in that case wouldn't represent a complete lack of satisfaction. It would just represent dissatisfaction. So oftentimes Likert scales are interval scales. Then ratio, again, true 0 point, much like interval, but 0 represents nothing. So some examples for ratio would be like number of credit hours. So if you say, how many credit hours are you taking? And someone says 0, well, they aren't taking any credit hours. And you can't have a negative number of credit hours. So that indicates a true 0 point. It's a ratio variable. Another one would be number of defectives. So if you're looking at the number of defectives for a batch of parts, it's truly numeric, so you know it's interval or ratio, and if you say 0 defectives, it means a complete lack of defectives. Another example would be slices of pizza. So if you say how many slices of pizza do you have 0, you have a complete lack of pizza, and it's a truly numeric value. So I know it's kind of difficult to identify those different scales of measurement, but with practice, you'll get better and better at it. So now that I've overloaded you with the scales of measurement, let's look at another distinction of data that is a little more basic, and it's based on being discrete or continuous data. And this is just relative to quantitative values. So quantitative values can either be discrete or can be continuous. So discrete variables are variables that have values that are limited to whole numbers. So data can only be certain values. So for example, if you wanted to examine gas station success based on the number of cars visiting, you'd be counting the number of cars, right? That would be a discrete variable. Or maybe you wanted to count the number of defective parts. Well, you can't have a fraction of a defect. It's either defective or it's not, so values would be limited to whole numbers and you would have a discrete variable. Now, continuous variables have values that can be divided. So data can really be any value, be a fraction or a decimal or a whole number. So for example, if you wanted to examine gas station success based on the number of gallons of gas sold, you'd be measuring the amount, not counting the number of cars, but measuring the amount. And you can have a fraction of a gallon of gas. Continuous data is not always obvious in situations where qualitative characteristics are measured, though. So even if it doesn't appear that you can have a decimal or a fraction, sometimes that variation in between whole number responses is implied. So for example, when you have a Likert scale measuring agreement or the extent of something like pain, you don't really assume that there are fixed levels of what's being measured without anything in between numeric response options. So most Likert scales assume that someone can be any value or degree within the lowest and highest points of the scale. So for example, someone may really be between hurting a whole lot and being in the worst pain imaginable. So maybe they're more of a 9.5, even though the scale doesn't really have that available. So there's something called upper and lower real limits that gets at those, points in between whole number responses on a Likert scale. So upper and lower real limits kind of represent that gray area between numeric Likert scale responses. So the upper real limit is halfway above the score, and the lower real limit for a score is halfway below it. So someone with an observed score of 9 on the pain scale is actually assumed to have a real score between 8.5 and 9.5, with 8.5 being the lower real limit of 9 and 9.5 being the upper real limit of 9. Don't worry about the logistics of that too much, just keep it in mind that sometimes, most times, Likert scales are assumed to be continuous because it's assumed that people or things will fall somewhere in between whole number responses. So students often struggle with identifying the scales of measurement and whether or not a variable is in fact discrete or continuous. So I developed this flow chart that may look a little bit overwhelming, but I'm going to show you how to use it so that you can identify the scales of measurement and whether or not a variable is discrete or continuous without trying to look at a bunch of descriptions and figure it out on your own. You can just kind of follow these paths, and wherever you end up is going to tell you which type of variable you're looking at. And this is a tool that you're going to be using for the rest of the semester because your decisions about how to display data or which ways to explain data numerically are going to be primarily driven by the nature of the variables. Is it discrete or continuous, and what's the scale of measurement? So I'm going to give you a couple of examples of how to use this flowchart so you'll be prepared to use it on your own. So let's say that I asked you, what's the scale of measurement and is it discrete or continuous for golf score? So you would want to start off in this. So let's do golf score, for example. So you would start in this first box right here. So the first question you ask yourself, is this a numeric or quantified variable? And golf score is a number. So you would go to yes. Then you would have to ask yourself, okay, is there an equal distance between all potential sequential values? And the answer to this one would also be yes, because a golf score, and the way it works, basically a golf score tells you how many times you hit the ball over or under par. So if you have a hole that's a par 4, that means that you're expected to hit the ball 4 times to get it in the hole. So if you think about equal distance between potential values, the distance between a 1 and the 2 is the same as the distance between a 2 and the 3, is the same as the distance between a 3 and a 4, right? It's all 1 point incremental increases. Conversely, you could have negative values, right? If you hit under par, then you would have a -1 or a -2, and the difference between a -1 and a -2 is the same as the difference between a -2 and a -3. So that's what I mean by, is there an equal distance between all potential sequential values? So golf score, yes, there is. So now we have to ask ourselves, do values have a true 0 point? Or in other words, can the value never be negative? Well, remember, I just said a golf score can be negative. If you have a negative score, that's a good thing. It means that you have hit the ball fewer times than what you would be expected for par. So in this case, we would say, do values have a true 0 point? No, they do not. So now we're here. So now we ask ourselves, are the values limited to whole numbers? And in this case, the answer is yes, because you can't have a fraction of a putt. So it's just 1, 2, 3, 4, -1, -2, -3, -4, fixed to whole numbers. So now we've landed on interval and discrete. So golf score is interval and discrete. It's a numeric value. It tells you the magnitude and direction of differences, and it's fixed to whole numbers. So let's do another example. Let's see. So if we do quiz grade. All right. So is this numeric or quantified variable? And yes, it is. So we would go to here. And then we'd say, is there an equal distance between all potential sequential values? And yet again, I'm going to say yes. All right, because think about it, right? The difference between a 55 and a 56 is the same as the difference between a 56 and a 57. Even if you look at the decimals, all the sequential values are truly numeric, so there's going to be equal distances between them. All right, now let's think about, do the values have a true 0 point and can never be negative? And I'm going to go ahead and go with yes, because you're not going to have a negative quiz grade. A 0 is pretty much the bottom of the barrel there. Now we have to ask ourselves, are values limited to true whole numbers? And in this case, the answer is no, because you can have a fraction or a decimal in your quiz grade, right? You could have an 89 or an 89.5 or an 89.2 or whatever. Pretty much all of the values are possible. So now we've landed on ratio and continuous. So quiz grades would be considered ratio and continuous. We're on a roll. Let's do another one. Okay, let's think about like the sex or the gender of the employees at your organization. All right, is this a numeric or quantified variable? No. Even if you quantified it for data analysis purposes, 0 or 1, it's really meaningless. You're not really quantifying it, you're just labeling it still, right? You're just categorizing it. So now we have to ask ourselves, okay, are values for this variable in an arbitrary order? So for instance, if you in your data set assigned 0 to females and 1 to males, that's completely arbitrary, right? It really has no meaning. It's meaningless. So we would say, yes, it's arbitrary. It's meaningless. So we have nominal and discrete data. Let's try another one. Examples are good. Let's do maybe the number of employees that quit last quarter. So number of quitters, like as a measure of turnover. Is this numeric or quantified? Yes, it is. Is there an equal distance between all potential sequential values? Yes, there is. And then we say, okay, right? Because 1 and 2, same difference between 2 and 3 and all that. Then we say, do values have a true 0 point? Yes, in fact, it does, right? Because you can't have a negative number of employees that quit. Are values limited to whole true numbers? Yes, they are, right? You can't have a fraction of an employee. We're not going to be cutting anybody in half. So we land on ratio and discrete for the number of employees who quit last quarter. Let's do another one. Let's say that I measured employee satisfaction on a scale from 1, not at all satisfied, to 7, extremely satisfied. So we're taking something that is qualitative and we're quantifying it. So is this numeric or quantified? Yes, it is. We've quantified it. Okay? Is there an equal distance between all potential sequential values? We're going to go ahead and go with yes for this one. Because there's 1, 2, 3, 4, 5, 6, 7 in the scale. So all those values are really laid out numerically with equal distances between those scores. Now we ask ourselves, do those values have a true 0 point and can never be negative? Now this is tricky because in the scale, you can't have negative values, right? It goes from 1 to 7, but there's not really a true 0 point. Remember, a true 0 point means that never or none has to be there, right? To where if there was a 0 for this variable, it means a complete absence of whatever we're measuring. So we are going to say no, there's not a true 0 point. And now this one is tricky too. Are values limited to true whole numbers? True whole numbers. Now remember, this Likert scale measuring satisfaction from 1 to 7, it looks like it's limited to whole numbers, right? 1, 2, 3, 4, 5, 6, 7, but there is an implied gray area between all of those numbers. If somebody rates themselves as a 2, maybe they're kind of like a 2.5, 1.5, but they were kind of restricted to the scale that was provided. So whenever you have a Likert scale that's measuring something that's qualitative, unless it's frequency based where you would say never and that means none, then you're going to go ahead and say that that is going to be a continuous scale. So for the most part, Likert scales that are designed to measure things that aren't necessarily numeric are typically interval and continuous. All right, one more. Let's look at the birth month of employees. Like you're trying to strategize birthdays to celebrate at work. So birth month. All right. Is this numeric or quantified variable? Not really, right? November, December, January, February, those aren't numeric things. Granted, you could assign numbers to those like the first month, the second month, and the third month, but they're not really numeric, but we could quantify them in that way. So let's just go ahead and say that it is, you can't really quantify it. So let's go ahead and say no. And then are values in an arbitrary order? No, it's not arbitrary, right? Birth month can be placed in a meaningful order. January comes before February. February comes before March, and so on. So this would have us on ordinal and discrete data. So I hope that you found this exercise useful and the examples really help guide you in using this flowchart.